Welcome to Statistic. My name is Dr. Twane. Please, if you have not subscribed to our channel, do well to subscribe. Our topic today is Chi-squre, particularly the Chi-squre test of independence. You know, in categorical data analysis, the Chi-squre, we have Chi-squre test of independence, we have the Chi-squre test of homogeneity, and also we have the Chi-squre test of goodness of fit. This is the problem we have to solve. In a study to ascertain the association between marital status and level of education, the data collected from 200 respondents are tabulated below. You are required to conduct the Chi-squre test at 0.05 level of significance. Now, this question can be a little more explicit than this. That is to indicate that you conduct the Chi-squre test of independence. Unfortunately, it is not in this question. So how will you know that what you are required to do is a Chi-squre test of independence? Now, if you look at the question very well, you see that we said in a study to ascertain the association between marital status and level of education. So which means we want to find out whether marital status is independent of level of education. So you will know that what you have to conduct is Chi-squre test of independence. Now, you are also informed that the test be carried out at 0.05 level of significance. So we just say that our alpha level is 0.05. Now, the next thing to do is to state our hypothesis. So we'll say HO, that marital status is independent. Marital status is independent of level of education. Marital status is independent of level of education. So that the alternate hypothesis is negation of HO. Or we can just state that marital status is dependent on level of education. Okay, so having stated the hypothesis, the next thing to do is to compute our test of significance. And so, the test of significance, our Chi-squre is given as, we say, double summation of O sub ij minus E sub ij all square, as our I goes from 1 to arrow and our J goes from 1 to C. All of that over E sub ij, where our E sub ij is the expected value and is given as your row total times the column total all over grand total. Or we can put it as row total times column total all over grand total. Okay? Okay. The next thing is for us to get a row total, it means that we have to sum across the row. And so if we sum this, 10 plus 20 will be 30, plus this 50, 60, 70. So this is 70. This is 15, 35, 65, 100. And so this is 5, 15, 30. That's the sum across the row. And so we also have to sum the column, so that this plus this will be 15, 20 plus 10 will be 30, 20 plus 20, 40 plus 5, 45. 10 plus 30, 40 plus 10, 50. 10 plus 30 will be 45 plus 15, 60. And so the sum of this is the same as the sum of this. So this plus this 170 plus 30 will be 200. And so this 200 is our grand total. The sum of the column and then the sum of the row will give us this 200. Okay, now let's call this cell 1, cell 2, cell 3, cell 4, and cell 5. Remember that we have just computed these columns. Remember that we have just computed this column. So our concentration is here. So if we call this cell 1, 1, meaning row 1, column 1, cell 1, 2, row 1, column 2, cell 1, 3, row 1, column 3, cell 1, 4, row 1, column 4, and cell 1, 5, row 1, column 5. So to get the expected value for cell 1, 1, we can call that E1, E1, 1. That's the expected value here. And that expected value is going to be our row total times the column total all over grand total. Now the total on the row is 70, and that will be times the total on the column, which is 15. 70 times 15 all over 200. So, and that will be equal to, if we multiply 70 by 15, 1050 all over 200, and that will be equal to 5.25. So the expected value, this is observed. Now call this expected. The expected value for this particular cell is going to be 5.25. Okay? Now for E12, which is row 1, column 2, it will be equal to, now the row total there is 70 and the column total is 30. So we'll have 70 times 30 all over 200. And that will be equal to 70 times 30 will be 2100 all over 200, which is 10.50. Okay? So now the next thing will be our E13, which is the row total is 70 and the column total is 45. So we'll have 70 times 45 all over 200. And that will be equal to 70 times 45, 3150 all over 200. And that will give us 15.75. Okay? Now, the next is E14, which will be 70. The row total is 70, and then the column total is 50. So we have 70 times 50 all over 200. And that will be equal to 70 times 50 will be 3500 divided by 200. And that will be equal to 17.50. So the next is E15, which will be equal to the total on the row is 70 and the total on the column is 60. So we'll have 70 times 60 all over 200. And that will be equal to 4200 divided by 200. And that will be equal to 21. Okay? So the next will be E21. So these values we have computed now, this we have computed as 10 the expected value here is 10.50. The expected value here is 15.75. The expected value here is 17.50. And the expected value here is 21. And so if we sum this value, it will also give us 70. Okay. Now, the next is expected value for cell 2, 1, row 2, column 1. So the expected value here will be our row total here is 100 and column total is 15. So we have 100 times 15 all over 200. And that's going to give us 1500 divided by 200, which is equal to 7.5. Okay? Now, so this is 7.5. Now for cell 2, 2. So we have E expected value for 2, 2 will be equal to, now the row total is 100 and the column total is 30. So we have 100 times 30 all over 200. And that will be equal to 3000 all over 200, which will be 15. So the expected value here is 15. Now we'll continue with the computation of our expected value. And the next will be, so our E, 2, 3, cell 2, 3, which is this, row 2, column 3. And that will be equal to, the total for row 2 is equal to 100 times the total for column 3 is 45. So we have 100 times 45 all over 200. And that's equal to 4500 divided by 200. And that will give us 22.50. So that our E24 will be equal to, now the total there is 100 divided by the total on the column is 50. So we have 100 times 50 all over 200. And that will be equal to 5,000 divided by 200, which will be equal to what? 25. Okay? So that our E25 will be equal to 100, the row total, times 60, which is the column total over 200. And that will be 6,000 divided by 200, which will be equal to 30. Okay? So we have here as 22.5, the expected value here. The expected value here is 25, and then the expected value here is 30. Okay? Now let's look at row 3, column 1. So we'll call it E1, E3, 1, which will be equal to, the total on that row is 30 times the total on the column is 15 all over 200. And that will be equal to 30 times 15, 450 all over 200. And that's equal to 2.25. So that our E32 will be equal to, the total on the row is 30, and the total on the column there is 30 all over 200. And that will be equal to 900 over 200, which is equal to 4.50. Our E33 will be equal to the total on the row is 30 and the total on the column is 45 all over. The grand total is 200. Okay? And that will be equal to 30 times 45. 1350. That divided by 200 will be equal to 6.75. Okay? So that our E34 will be equal to the total on the row is 30 times the total on the column is 50 divided by 200. That will be equal to, now 30 times 50 is 1,500 all over 200. That's going to give us a 7.50. And the last expected value is our E35, which is equal to the total on the row is 30 and the total on the column is 60 divided by 200. That will be equal to 1,800 divided by 200, which is equal to, okay, that's 9.00. So the expected values will be for E31 is 2.25, and then this is a 4.50, and then 6.75, 7.50, and then 9.00. So if you sum this, it will also give you 30. Okay? So let's note that this is the sum of the expected values, so that you are not adding it and thinking it will give you this 200. The same thing is applicable here. If you add the expected values, it should also give you this 30. If you add the observed values, it should also give you this 30. Now, to continue with the computation of our test statistics, which is Chi-square is equal to double summation of our O's of ij minus E's of ij square, as I goes from 1 to R or J goes from 1 to C, all over this expected value. We say observed minus expected square all over expected. Now, to compute this, we can directly use a calculator to say this observed minus this expected square over this expected plus this observed minus this expected square over this expected plus this observed minus this expected square divided by this expected plus this observed minus this expected squared divided by this expected. And by the time you do for all of the values, it will directly give you the chi-square calculated. But the thing is, there is the possibility of making mistake along the line. But if you can do that, it's very simple. It means that there would have been the end of computing our test statistics. But to make it easier or to make it clearer, then we are going to tabulate this. Create a column for the observed, create another column for the expected, so that we just use that table to compute our test statistics, and it will just be seamless or straightforward. Okay. The observed values. Just count them for me. Column, follow the column. 20. Along the rows, we have 10, 20, 20, 10, 20. And at the second row, we have 5, 15, 20, 20, 35. And along the third row, we have 0, 0, 5, 10, 15. And so the values we computed as the expected values are haven't tabulated the observed and the expected. The next will be, so if you look at the formula, we said observed minus expected. So we'll create another column and call it observed O sub ij minus expected E sub ij. So 10 minus 5.25. 20 minus 10.5. 20 minus 15.75. So the next thing from the formula is observed minus expected square. So to square this value, we have O sub ij minus E sub ij square. So which will be the square of these values? So 4.75 square will give us, okay, so we have 9.50 square. 90.25. So the square of this is, okay. Okay, so the next thing, according to the formula, will be our observed minus expected all square divided by the expected. And so if we divide this by this value, it will give us, okay, so dividing this by this, and this by this, such that the summation of these values, the sum of these values is going to be our chi-square value, which we say is the double summation of all over our EIG. That will be equal to, so the sum of this value, which we have already divided by this, is equal to, so as it is now, our computed or calculated chi-square is 39.66. Note that our decision rule is that we reject HO if our chi-square calculated is greater than our chi-square critical, the alpha under a certain degree of freedom. So now our degree of freedom is giving us number of rows minus 1 times number of columns minus 1. And that will be equal to, we have the number of rows from what we are given is equal to 3, and then minus 1 into the number of columns is 5 minus 1. All of that will be 2 times 4, which is equal to 8. So if we look at our chi-square 0.05, the level of significance, which is this alpha, is 0.05. We are told that from the initial time. And then under the degree of freedom is 8. And so if we look at our table, that's going to give us 15.51. So our computed chi-square is equal to 39.66. And that value is greater than the calculated chi-square at 0.05 under 8, which is equal to 15.51. 5, 1. Therefore, we reject the none. And when we reject the non hypothesis, then it means that we are going to uphold the alternate. Remember again that the non hypothesis said that marital status is independent of level of education. And so we are upholding that marital status is not independent of level of education. In fact, marital status depend on level of education. Thank you very much. Do well to subscribe to our channel, like our video, share with your friends. God bless you.